We shall now go through some more important and main problems in definite integrals. Out of them, the very first problem is integral 0 to pi by 4 log of 1 plus tan theta d theta. We know that integral 0 to a f of x dx is equal to integral 0 to a f of a minus x dx, isn't it? Let us now make use of that formula. This is equal to integral 0 to pi by 4 log of 1 plus tan pi by 4 minus theta d theta. Again, integral 0 to pi by 4 log of what is tan pi by 4 minus theta? 1 minus tan theta by 1 plus tan theta d theta. This is equal to integral 0 to pi by 4 log of LCM is 1 plus tan theta, and in the numerator 1 plus tan theta plus 1 minus tan theta d theta. So it is log of 2 by, hence it is integral 0 to pi by 4 log 2 minus log of 1 plus tan theta. Let me name this as I, so that what do you have? I is therefore equal to integral 0 to pi by 4 log 2 minus integral 0 to pi by 4 log of 1 plus tan theta, again the given problem. Bring that I this side, so that this is 2I is equal to log 2 into integral 0 to pi by 4 1 d theta. And actually automatically this is pi by 4 log 2 into pi by 4. Hence I is therefore equal to pi by 8 log 2. Pi by 8 log 2. See, it is so famous that you may be remembering that answer. Pi by 8 log 2 integral 0 to pi by 4 of log of 1 plus tan theta is nothing but pi by 8 log 2. It's a beautiful question, famous and standard question. It is a lengthier question, but the answer is so short. It is given on the board. You please look at that. F is a positive function. It does mean that f of x is always greater than 0, and integral 1 minus k to k x into f of x into 1 minus x dx is I1, and integral 1 minus k to k f of x into 1 minus x dx is I2. Then he requires the ratio I1 by I2. What will be I1 by I2? Look here. I1 is equal to integral 1 minus k to k. Well, consider this as A, this as B. In our earlier formula, integral a to b f of x dx can be taken as integral a to b f of a plus b minus x. Am I correct? Now if you consider a as 1 minus k and b as k, I1 is equal to integral 1 minus k to k. Well, in the place of x, I like to put a plus b minus x. A plus b is 1. 1 minus k plus k is 1 minus x. So it is 1 minus x into f of 1 minus x into x dx. Well, this is I1, this is I1. I like to add this. 2I1 is equal to, come on, integral 1 minus k to k. Come on friend, x, this and this, if you add these two functions, if you get f of x into 1 minus x as a common factor, you have x into 1 minus x plus 1 minus x. What is that? F of x into 1 minus x dx you have. Just like that. And this is nothing but I2, isn't it? 2I1 is equal to I2. From this we can have I1 by I2 is therefore 1 by 2. What is the required ratio? I1 by I2 is equal to 1 by 2. Look at the question. Question is lengthier. Answer is short. Question is big, but the answer is very, very simple, isn't it? We could have made use of this character, this property. Integral a to b f of x dx is equal to integral a to b f of a plus b minus x dx. Integral minus a to a cos square x by 1 plus a power x dx. It's a beautiful problem. Every problem we are tackling with, we are dealing with is a famous problem. It is also one of such. Well, to make an attack on this problem, you see, minus a to a is given. Generally, every student prefers to test this integrand whether even or odd. You cannot say it is even or odd. Therefore, we may have to go for another process. Look here, integral minus a to a f of x dx can be written as integral 0 to a f of x plus f of minus x dx. In general, for any function, whether it is even or odd, of course, if f is even, f of minus x becomes f of x plus f of x is 2 into f of x. So, formula is right. If at all f is odd function, then f of minus x is minus f of x and plus f of x will be cancelled, so that 0, then also the formula stands true, as of course. So, to remember this formula only, I have discussed all those things. Well done. F of x is cos square x by 1 plus a power x. Good. This is therefore integral 0 to a f of x plus f of minus x. I would like to make use of that formula. F of x means cos square x by 1 plus a power x. F of minus x means cos square of minus x by 1 plus a power minus x dx. Am I correct? Good. Next one, integral 0 to a cos square x by 1 plus a power x plus, what is cos square of minus x? Cos square x. There will be no change at all. See, a power minus x is available in the denominator. To nullify that, I like to multiply both numerator and denominator with a power x. What happens? You observe. Good. This is integral 0 to a. You pull cos square x out. LCM is a power x plus 1. Numerator is 1 plus a power x. What is happening? These two can be cancelled, leaving you integral 0 to a cos square x has been remained. And for cos square x, you can write it as integral 0 to a 1 plus cos 2x by 2. For cos square x, you can write 1 plus cos 2x by 2. This is equal to integral 0 to a half into 1 plus cos 2x. That is, what is the integral of 1? X. For cos 2x, sin 2x by 2 between the limits 0 to a, hence it is half into a plus sin 2a by 2. That gives you the answer. That is the answer. So, the crucial part here is making use of the formula integral minus a to a f of x dx is equal to integral 0 to a f of x plus f of minus x dx. Follow this. The next question is integral pi to 10 pi mod sin x dx. Pi to 10 pi means you may have to split pi to 2 pi, 2 pi to 3 pi, 3 pi to 4 pi, 4. Oh, there will be a lengthier chain. But you see, we have a beautiful formula, integral a to a plus nt f of x dx is there. If f of x is a periodic function with period t, then integral a to a plus nt of f of x dx is equal to n into integral 0 to t of f of x dx. You can have a beautiful formula is there regarding periodic functions, and here mod sin x is periodic with period pi. Sin x is periodic with period 2 pi. Mod sin x is periodic with period pi. Pi to 10 pi he is asking you, therefore it is integral pi to pi plus 9 pi of mod sin x. Use that formula. In the place of n, what are we having? 9. 9 into integral 0 to pi mod sin x. Because it is with period pi. Well, between 0 and pi, what is mod sin x? Observe the graph of sin x. 0, 90, 180. Between 0 and pi, the graph of sine function lies above x-axis, so it is always non-negative. Therefore, in the place of mod sin x, what can you write? Just sin x. So, this is 9 into integral 0 to pi sin x dx. Of course, we know that integral of sin x is minus cos x, hence it is minus 9 into cos x between the limits 0 to pi. Good. The answer is minus 9 into cos pi is minus 1, cos 0 is 1, so the answer is 18. Answer is 18. It's a very good problem making use of the concept of periodicity. Have a note of that. This is the question. F of x is equal to e power cos x into sin x for mod x less than or equal to 2 and 2 otherwise. It does mean for any other x for which mod x is greater than 2. Okay, this is the question we are asked. This is equal to integral minus 2 to 2 f of x dx plus 2 to 3 f of x dx. I would like to split like this. Why? Because up to 2 one particular definition is there, otherwise another definition is there. Therefore, the function f of x has a particular change at 2 only. Therefore, I could have changed this or expressed this integral as the sum of 2 integrals. This is equal to integral minus 2 to 2 f of x. What is f of x? E power cos x into sin x. E power cos x into sin x dx plus integral 2 to 3. What is f of x in this case? It is 2. Okay, minus 2 to 2 e power cos x into sin x. What do you feel about it? Is it even or odd? Cos of minus x is cos x, but sin of minus x is minus sin x, hence it is an odd function, absolutely odd function. E power, you call this f of x. E power cos of minus x into sin of minus x, isn't it? So it is minus e power cos x into sin x, hence it is an odd function, hence the answer is 0, and for that it is 2 into x between the limits 2 to 3, hence the answer is 2. The next question, I think you could have followed this. The function, the definition has been given in at 2 phases for mod x less than or equal to 2. This is the definition to be followed. And f of x is a constant function otherwise means for any x whose modulus is greater than 2. That is this. Keeping this only in mind only, we could have divided this integral as the sum of 2 integrals. Yes. So the answer is 2. Observe the question. The next question before us is pi by 2 to 3 pi by 2 integral part of 2 sin x dx. Integral part of 2 sin x dx. Let me take x is equal to pi by 2 minus t. What happens? Then dx is equal to minus dt. Minus dt. Although also the limits also will be changed. X is equal to pi by 2 implies t is equal to 0. And x is equal to 3 pi by 2 implies 3 pi by 2. Okay. You take pi by 2 plus t. So that x is equal to pi by 2 means t is equal to 0. X is equal to 3 pi by 2 means 3 pi by 2 minus pi. 270 minus 90, 180, that is equal to t is equal to pi. Now, this integral can now be changed as, instead of pi by 2 to 3 pi by 2, we are supposed to have 0 to pi. X is pi by 2 plus t, sine of pi by 2 plus t is cos t, isn't it? 2 cos t dt. 2 cos t dt. Now, observe the cosine graph of the cosine function. Cos 0, 1, 2 ones are 2. Again, cos 60, half. Cos 60, half. 2 into half, 1. Then also it becomes an integer. Again, cos 90, 0. Then also it is an integer. Again, $120, it is minus half. 120, it is minus half. Again, 180, 0. So, this particular 2 cos t becomes an integer at what type of points? At 0, it is an integer, 2 ones are 2. At pi by 3, 2 halves are 1. At pi by 2, it is 0. At 2 pi by 3, that is 120 degrees. It is 2 into minus half is minus 1. And at pi, that is 180 degrees. It is minus 1. Then also it is an integer. Therefore, I would like to split it as integral 0 to pi by 3. Integral of 2 cos t plus integral pi by 3 to pi by 2. Integral part of 2 cos t plus integral pi by 2 to 2 pi by 3. 2 cos t, and at last integral 2 pi by 3 to pi 2 cos t. Observe it carefully. Between 0 and pi by 3. Between 0 and pi by 3. At 0, it is 1. If you go on, proceed up to pi by 3, it will be decreasing. Isn't it? Therefore, it is 2 into that part is 2 pi by 3 is half. It is half. At this point, 2 into half is 1. At this point, 2 into something, it is greater than 1. But, isn't it? Exactly here, it is 1. 2 into half, 1. It is 2 into more than half is greater than 1. 1 point something. Hence, this part it is 1 plus pi by 3 to pi by 2. Here, let it be some casting. Let us understand the position here. T lies between pi by 3 and pi by 2. Then cos t lies between pi by 3 less than t less than pi by 2. Then cos pi by 3 greater than cos t greater than cos pi by 2. That is cos pi by 3 half greater than cos t greater than 0. Multiply it with 2. 1 greater than 2 cos t greater than 0. So 2 cos t is less than 1. Less than 1 means in this part it is 0. 2 cos t is less than 1, hence it is integral part of that is less than, is nothing but 0. Forget it. Plus pi by 2 to 2 pi by 3. What can you understand by that? See, t pi by 2 is less than t is less than 3 pi by 2. Pi by 2 is less than 3 pi t less than 3 pi by 2. Then cos pi by 2 is greater than cos t greater than cos 3 pi by 2 is minus half. Isn't it? Cos pi by 2 greater than cos t greater than cos 3 pi by 2. Cos pi by 2 is 0. 0 greater than cos t greater than minus 1 by 2. Minus 1 by 2 less than cos t less than 0. Multiply it with 2. Minus 1 less than cos t less than 0. 2 cos t less than 0. If you multiply this with 2, minus 1 less than 2 cos t less than 0. So between minus 1 and 0, for that value, integral part is minus 1. Hence, this is minus 1. Pi by 2 to 2 pi by 3. This is minus 1. And the last one, 2 pi by 3 to pi. 2 pi by 3 to pi. Suppose here cos t is less than cos pi. It is less than minus 1. It lies, see, it is less than minus 1. For this one, cos t is less than cos pi, which is cos pi. Cos pi is less than 0. Less than 0, it lies here. So for that also it is minus 1. For that one also it is minus 1. Like that you have to split the interval, and these integrals are very easy to be obtained. You can get with simple numerals. The next problem before us is integral 0 to 1 root of 1 minus x by 1 plus x. Integral 0 to 1 root of 1 minus x by 1 plus x. Can you use integral a to b, a minus x, x minus a and b minus x? You cannot use that. You cannot use. Isn't it? Therefore, this can be taken as integral 0 to 1 minus x by root of 1 minus x square. I think you could have observed this. What I have done, it seems you might have followed. This is equal to integral 0 to 1 by root of 1 minus x square minus integral 0 to 1 x by root of 1 minus x square dx. I have split into two parts. One more thing you can do, make it plus and make it minus 2. What is 1 by root of 1 minus x square? Sin inverse x between the limit 0 to 1. Here f dash x by root f x. F dash x by root f x. What is f dash x by root f x? 2 root f x. That is 2 into root of 1 minus x square between the limits 0 and 1. For this is sin inverse 1 is pi by 2. Sin inverse 0 is 0. Plus, if you put 1, it is 0. If you put 0, it is 1. So altogether the answer is pi by 2 minus 1. It is one of the standard problems. The next problem before us is integral 0 to 2 mod x minus 1 dx. This can be taken as 0 to 1 mod x minus 1 dx plus 1 to 2 mod x minus 1 dx. Come on friend, why is it necessary to split into two integrals? The main function given is mod x minus 1. You see? 0, 1, 2. Suppose x is here. X is less than 1. What is mod x minus 1? 1 minus x. Suppose x is here. X is greater than 1. What is mod x minus 1? X minus 1 itself. That is, mod x minus 1 takes two different values behind 1 and beyond 1. Behind 1 it is 1 minus x, beyond 1 it is x minus 1. That is why by keeping that point in view, I could have divided into two types of integrals. So that it is, come on tell me, 0 to 1, mod x minus 1, x lies here, x is less than 1. The distance means it is 1 minus x. Plus between 1 and 2, x is less than 2, that is x is greater than 1. X is greater than 1 means distance is x minus 1. X minus 1 dx between the limits 1 to 2. Therefore, it is, come on tell me, for 1 it is x minus x square by 2 between the limits 0 to 1 and x square by 2 minus x between the limits 1 to 2. Come on tell me, if you take x equal to 1, it is 1 minus half, 0 is 0, plus if you take 2, 2 square by 2, 4 by 2 minus 2. If you take 1, 1 square by 2, 1 by 2 minus 1. 1 minus half is half, 2 minus 2 is 0, half minus 1 is minus half is plus half, half plus half is, answer is 1. Answer is 1. The next problem. This is the question. F of x plus f of 1 by x is equal to capital F of x, where small f of x is given to be integral 1 to x log t by 1 plus t dt. He has asked us to have f of e. How to get that f of e? Look here. F of e is equal to f of e plus f of 1 by e. F of e is nothing but 1 to e log t by 1 plus t dt plus 1 to 1 by e log t by 1 plus dt. Is equal to I1 plus I2, say. You call it. Don't touch I1. Think of I2. Let 1 by t is equal to u. 1 by t is equal to u, or t is equal to 1 by u. T is equal to 1 by u. Then dt is equal to minus 1 by u square du. U square du. Then what about the limits? If t is equal to 1, u is also 1. If t is equal to 1 by e, then 1 by e is equal to 1 by u, so it is u is equal to e. Basing all these things, what is I2? You just simplify I2. Integral 1 to 1 by e becomes integral 1 to u. Log t, what is log t? Log 1 by u is minus log u. What is 1 plus t? 1 plus 1 by u. What is dt? Minus 1 by u square du. Minus and minus of course gets cancelled. This is equal to, multiply this with u square. What happens? U square plus, this is 1 plus 1 by t. So it is log u integral 1 to e log u du by u square plus u. U square into 1, u square into 1 by u. So that integral of log u by u into 1 plus u du between the limits 1 to e. So far we have been simplifying I2 only. What is I1 plus I2? What is I1? Integral 1 to e log t by 1 plus t dt plus I2 1 to e. I am not changing the function. The limits 1 to e log t dt by t into 1 plus t. Without changing the function, without changing the limits, changing the parameter makes no difference. That is why I have taken this. Well, you add these two. Integral of 1 to e of log t by 1 plus t into 1 plus 1 by t. What is 1 plus 1 by t? T plus 1 by t. Integral 1 to u log t by 1 plus t into 1 plus t by t. At last, log t by t, log t into 1 by t dt. F of x into f dash x dx, f of x whole square by 2, that is log t whole square by 2 between the limits 1 to e. If you put e there, log e is 1, 1 square is 1, 1 by 2. If you put 1, log 1 is 0. So the answer is half. So the crucial portion lies in the solution is this. You are supposed to take t is equal to 1 by, thereby getting the answer as 1 by 2. F of e could be directly obtained. In f of e, f of 1 by e makes produces some steps here. Anyway, it's a good problem. Follow that. The next problem is this. Integral minus half to half integral part of x plus log of 1 plus x by 1 minus x. This can be split into two integrals. Let us do that. Minus half to half integral part of x dx plus minus half to half log of 1 plus x by 1 minus x. And in the beginning itself, we could have noted that log of 1 plus x by 1 minus x is also an odd function. And as this is an odd function, let us recall the formula. Integral minus a to a f of x dx is therefore equal to 0 if f is odd. We have had it. So by that one, this is 0. So that this only remains. Now I like to split this as minus half to 0 integral part of x dx plus 0 to half integral part of x dx. Well friend, if x lies between minus half and 0, minus half and 0, minus half and 0, this is minus 1, this is minus half. Minus half and 0, for all those real numbers lying between minus half and 0, integral part is minus 1, isn't it? So integral of minus half to 0 minus 1 dx plus, if x lies between 0 and half, this is half. For all these values, integral part is 0, hence plus 0 dx, 0 to half. This second part is already 0. This is minus 1. It is minus x. Minus x between the limits minus half and 0. If you put x is equal to 0, it is 0. If you take minus half, it is half. Hence the answer is 1 by 2. In the beginning, the question looks so big or bulkier, but this part is an odd functional part that becomes 0. Therefore, it is just enough to find this integral, which is of course 1 by 2. Integral 0 to 1 x into 1 minus x whole cube dx. The next problem before us is integral 0 to 1 x into 1 minus x whole cube dx. It is also a very simple question. No steps are needed. You can directly have the answer. The only thing that is required is you may have to recollect the formula integral 0 to 1 x to the power of m into 1 minus x whole to the power of n dx is equal to m factorial into n factorial by m plus n plus 1 factorial. Making use of that formula, in the place of m, what are we having? 1. In the place of n, 3. So the answer is 1 factorial into 3 factorial by 1 plus 3 plus 1 factorial. That is equal to 6 by 120 is 1 by how many times? 20. Answer is 1 by 20. The next question is ready before us. 3 into f of x plus 2 into f of 1 by x is equal to 1 by x minus 5 for all x not equal to 0. Then integral 1 to 2 f of x dx is. This is the question. And to answer this question, you must be provided with f of x. What f of x is? The first duty, the first piece of work that must be done is you find f of x. How to find it? Look here. 3 into f of x plus 2 into f of 1 by x is this. Let me call this 1. In this given information, you take 1 by x in the place of x. What happens? 3 into f of 1 by x plus 2 into f of x is equal to x minus 5. Am I correct? Call this equation 2. Okay, what do you want to have? We want to have f of x. You try to eliminate f of 1 by x from these two equations. What happens? Multiply the first equation with 3. Multiply the second equation with 2 and subtract. What is the fate of f of x? 3 into 3, 9 f of x minus 4 f of x is 5 into f of x. 6 f of 1 by x minus 6 f of 1 by x, so f of 1 by x will be cancelled. What happens? We are multiplying the first equation with 3. Therefore, 3 into 1 by x minus 5 minus 2 into x minus 5. Total, this is 3 into 1 by x is 3 by x minus 15 minus 2x plus 10. So that this is 3 by x minus 2x minus 5. What is this? Is it f of x? No, 5 into f of x. Therefore, f of x is equal to 1 by 5 into 3 by x minus 2x minus 5. Now you integrate this with between the limits 1 to 2. The only thing which looks new here is this. Okay. Therefore, integral 1 to 2 f of x dx is equal to integral 1 to 2 1 by 5 into 3 by x minus 2x minus 5 dx. 3 by x is nothing but 3 log x minus x square minus 5x between the limits 1 to 2. Let us first substitute 2. 1 by 5 into 3 log 2 minus 2 square. Next, let us substitute 1. 3 log 1 is 0 minus 1, minus 5, minus 6. Totality is 1 by 5 into 3 log 2 minus 4 minus 10 minus 14 plus 6 minus 8. That is the answer. As it looks, you may think that there is something special, what is to be done, what are the proper ideas, like that. But if you eliminate f of 1 by x, it will be very easy to have f of x and thereby integral of f of x between the limits 1 and 2. That is the question. Follow it carefully. Consider the question. Minus pi by 3 to pi by 3. F of x plus f of minus x into g of x minus g of minus x dx. Look at this question. What is f of x? Not given. What is g of x? Not given. But a lengthier integrand appears before us. Look here. We know that from the fundamental concepts of even functions and odd functions, any function which looks like f of x plus f of minus x is an even function, and that which appears in the form f of x minus f of minus x or g of x minus g of minus x is an odd function. Well done. Product of even function and odd function is again odd function. As this is odd function, integral minus pi by 3 to plus pi by 3 is absolutely 0. The only thing that you have to recollect here is any function which appears in the form f of x plus f of minus x is f of x plus f of minus x is an even function, and g of x minus g of minus x is an odd function. That's it. The next question, the next special problem before us is integral 0 to pi by 2 x sin x by cos power 4x plus sin power 4x. Let me call this I. Now, I like to make use of the formula integral 0 to a f of x dx can always be taken as integral 0 to a f of a minus x dx. Am I correct? I like to make use of that. Come on, use it. Integral 0 to pi by 2. Pi by 2 minus x into sin pi by 2 minus x into cos pi by 2 minus x by sin power 4x plus cos power 4x. This is I. Well, my dear, you add these two. I plus I becomes 2i. This plus this. Denominator is same. If you take sin x cos x as common factor, you have x plus pi by 2 minus x is pi by 2. Pi by 2 into sin x cos x. Okay. This is therefore equal to pi by 2 into integral 0 to pi by 2 sin x cos x by cos power 4x by tan power 4x plus 1 dx. I think you could have noted what I could have done. I have divided with cos power 4x. What happens? Is equal to pi by 2 into integral 0 to pi by 2 sin x by cos x by cos x 1 by cos square x dx by tan power 4x plus 1. Now I like to take tan square x as t. Tan square x as t. Pi by 2 into integral 0 to pi by 2 tan x into secant square x dx by tan power 4x plus 1. I am putting 1 2 here, taking 1 by 2 back. This is equal to pi by 4 into integral 0 to pi by 2 dt by t square plus 1, where tan square x is equal to t. 2 tan x into secant square x dx is equal to dt. Justly for that purpose only I have introduced 2 here and taken 2 here. Tan square x is equal to t, 2 tan x dx secant square x is equal to dt, well and good. X is equal to 0 implies t is equal to 0. X is equal to pi by 2 implies t is equal to infinity. Therefore, that is equal to pi by 4 into integral 0 to infinity dt by t square plus 1. We have changed the parameter, in the place of tan square we have taken t, therefore the limits are also to be changed. Okay, this is therefore pi by 4 into tan inverse t between the limits 0 and infinity. If you imagine infinity in the place of t, tan inverse infinity is nothing but pi by 2, pi by 4 into pi by 2 minus 0, hence the ultimate answer is pi square by 8. That gives you the answer. You see, this is all 2i but not I. Therefore, 2i is equal to pi square by 8, hence I is equal to pi square by 16. We have got 2i but not I. So, the I is pi square by 16. It is also a famous problem. Let us get it solved. My dear friends, you please observe the quantity available in the numerator. It is sin x plus cos x. Come on, what is its integral? Sin x minus cos x. So, keeping this in view, I like to take sin x minus cos x as t. Implies cos x plus sin x dx is equal to dt. Up to here, numerator it is okay. We will be going to write dt in the place of that numerator. What is the fate of this denominator? We may have to search for that. Come on, square on both sides. Sin x minus cos x whole square is equal to t square. Sin square x plus cos square x minus 2 sin x cos x d is equal to t square. 1 minus sin 2x is equal to t square, or sin 2x is equal to 1 minus t square. Okay, we could have got the plan of writing 1 minus 2 square in the place of sin 2x. Now you think of the limits. Change of limits. If x happens to be 0, then what is t? Sin 0 is 0. Cos 0 is 1, so minus 1. If x happens to be pi by 4, then what is t? T is equal to sin pi by 4 minus cos pi by 4, 0. Good. What is the fate of I? I is equal to integral minus 1 to 0 sin x plus cos x dx is dt by 9 plus 16 into 1 minus t square. That is 25 minus 16 t square, isn't it? Integral minus 1 to 0 dt by 9 plus 16, 25. 25 minus 16 t square. Minus 16 t square. It is in the shape of, you pull 1 by 16 out. 1 by 16 into minus 1 to 0 dt by 25 by 16 minus t square. This is in the shape of 1 by a square minus x square. 1 by a square minus x square, and it can be solved by using the formula 1 by 2a log mod a plus x by a minus x. Hence it is 1 by 16 into 1 by 2a. A is 5 by 4 into log mod 5 by 4 plus t, 5 by 4 minus t between the limits minus 1 and 0. Okay, this is 2 by 4 is 2. 1 by 40 into 4 goes 4 times, 4 tens of 40, 1 by 40 into If you put 0, 5 by 4 by 5 by 4 is 1, log 1 is 0. If you put minus 1, 5 by 4 minus 1 is 1 by 4. 1 by 4 by 5 by 4 plus 1, 9 by 4, 1 by 9. Minus log 1 by 9. It is nothing but 2 log 3 by 40 or log 3 by 20 is the answer.